In this video, I'm going to show you how you can use the calculator to solve binomial probability problems. In the last few videos, we've spent quite a lot of time looking at how to use the formula and where it comes from. That's a really important thing to understand, but the majority of your time will be spent using the calculator to work out these questions rather than using the formula. And it's actually very quick to do so. So let's have a read of this question, then we'll look at how to use the calculator to solve it. It is known that on average 85% of the seeds for a particular variety of tomato will germinate. Ramesh selects 15 of these seeds at random and sows them. Find the probability that exactly 12 germinate. So we should always start by writing down our distribution. So the number of seeds that germinate is going to have a binomial distribution. There are 15 trials because he plants 15 seeds, and the probability that each one of them germinates is 0.85. And the question is, what is the probability that the number that germinate is exactly 12? So rather than using the formula, here's how we use the calculator to do this. So here's my Casio ClassWiz calculator. You can do this though on all good scientific calculators. If you go to the menu, and then you scroll down and across to distribution, so not the statistics one, there's a separate distributions option. Click equals. Now you've got a range of different statistical distributions here. You've got a normal distribution, which comes up next year. Then we've got binomial PD, which we'll be using now. And if you scroll down, there's also binomial CD. The CD is a cumulative distribution. The PD is your probability distribution. So that's what we want now. So we use the PD if we're looking for the probability of a specific number. And in this case, it's the probability that X is 12. So I go with option 4. Now, there's a couple of options for how you do this, but I would recommend always going with option 2, variable. So go with 2. And now here's what we need to key in. X, that's the number of successes we're looking for. So it's 12 in our case. N is the number of trials, which is 15 in our case. P is the probability, which is 0.85. That is it. Click equals, and there is your answer, 0.2184. 0.2184. Now, rest assured that you will get full marks if you use your calculator and this is all the working you provide. If you can use the calculator, then you're allowed to. Okay, let's take a look at another example. A coffee shop provides free internet access for its customers. It is known that the probability that a randomly selected customer is accessing the internet is 0.35 independently of all the other customers. There are currently 13 customers in the shop. Find the probability that exactly 5 of them are accessing the internet. Okay, so here's my distribution. So the number who are accessing the internet has a binomial distribution. There are 13 customers in the shop, and the probability that each one of them is using the internet is 0.35, independently of all the others. So the condition of independence is met. And we're looking for the probability that exactly 5 of them are using the internet. So we get our calculator, and we do what we did last time, which is we go to the menu, go to our distributions, select option 4, which is our binomial probability distribution. It's variable that we always go for. Now, X is the number of successes, which is 5. N is the number of trials, which is 13. P is the probability of success, which is 0.35. And that gives us an answer of 0.2154. So 0.2154. Okay, so you can see that actually getting our probability answer is really straightforward using that calculator function, and it's not cheating. You are expected to do that, so please do use it. All right, that's all for now. I'll see you in the next video.